Hey guys, so this video is going to be on hypothesis testing using z-scores, okay? And the example I'm going to use is number 15 in the book, page 245, number 15, and this is the book that we're using, okay? So before I go into the sample problem, I wanted to do a quick overview of what we want when we do hypothesis testing, okay? This makes it easier for you guys to keep track of all the steps, and also it makes it easier for the TAs to grade when we're grading it, to make sure we're not overlooking something, okay? So step one. In step one, I want you to write it just like this, okay? Just like that. I mean step and then one and then circle it. And then in step one, we state the hypothesis, okay? So it'll always be H0 and H1. So H1 is our alternate hypothesis and H0 is our null hypothesis. So if it had no effect is our null hypothesis, and some effect is our alternate hypothesis. So the null hypothesis, there's no effect, and alternate hypothesis, there is an effect. Okay? Step two, identify critical region. Alright? So when you're identifying the critical region, it's important to know two things. First, you need to know, what's my alpha level? And in behavioral science, it's typically, the alpha level is typically 0.05 or 0.01. In other words, so what's alpha level? Alpha level is basically, what are the chances that this happened by chance? So when it's 5%, we can say the chances of this happening by chance is 5% when the alpha level is 0.05. When it's 0.01, we can say the chances of this happening by chance is 0.01. This is we can only say that when it lands in the critical zone. So, okay, let me draw this out real quick. If this was 5%, and it's a two-tailed test. So that the next thing we need to know is it one-tailed, or two-tailed? Okay. So if it's two-tailed, such as this, we have to divide our alpha level into two. So if this is 5% or 0.05, this region is 2.5%. This region is 2.5%. And I know the z-score corresponding to this is 1.96 and negative 1.96. Alright? If it was one-tailed, that means this whole region is 5%. I did that backwards. And I don't know what this corresponds to. Let's look real quick. So you want to look here, you want to look at the region proportion to tail, that is 0.05. 0.05. So it's roughly 1.65. Okay? So if it was a one-tail test, this number right here is 1.65. This is 0. Okay? So two-tailed, alpha 05, and this is one-tailed. Alright? Next thing we need to do in step 3, calculate observed value. Okay? So in this step, we calculate what the z is. In step 4, we state results, okay? And when we state the results, it's either one of two things, okay? The first thing is we reject the null hypothesis. The other option is fail to reject. Those are the only two options, okay? You cannot accept anything. I cannot emphasize that enough. We can't accept the null. We can't accept the alternate hypothesis. The reason is because there's always some percentage of error. We can't accept anything 100%. All right. In step 5, we state the conclusion. I don't know. Verbally, I guess. I don't know. Basically, you have to state it so that it's understood. Because if you put reject null hypothesis in a report, and that's all you say, most people won't understand what that means. Okay? So, let's go start in our example. If you guys want to read along, because I'm not too good at reading. Alright, so number 15, page 245. A psychologist is investigating the hypothesis that children who grow up as the only child in the household develop different personality characteristics than those who grow up in a larger family. Okay? A sample of n equals 30 only children is obtained, and each child is given a standardized personality test. For the general population, scores on the test form a normal distribution with a mean of 50 and a standard deviation of 15. If the mean for the sample is 58, can the researcher conclude that there's a significant difference in personality between only children and the rest of the population? Use a two-tailed test and an alpha level of 0.05. Okay, so they give us everything we need, okay? Number 15, page 245. Alright, so let's always write down your knowns, okay? N equals 30. What else do they tell you? They tell you that the mu is 50. Standard deviation is 15. The mean for the sample is 58. Alright. They want us to use a two-tailed test. And they want us to use an alpha of 0.05. Great. Now we have everything we need. What's the first step? First step is we state our hypothesis. Alright, so let's see. Can the researcher conclude that there's a significant difference in personality between only children and the rest of the population? So I always write H0, H1. And then I always write H1 first, okay? So if there is a difference, then this should not equal 50. But if there is no difference, then this should remain the same. Okay? Difference, no difference. Alright. Step 2. Step 2, find the critical region, right? So we have to write it exactly like this. Alpha level is 0.05. Two-tailed. Z crit is equal to plus or minus 1.96. And how do I know it's 1.96? Because I looked at the unit normal table and I went to the proportion of the tail that corresponds to 0.025, which is 2.5% on each end of the tail, and that number is 1.96. Okay? And you have to do two-tailed. That means on both ends here 2.5, 2.5, remember this? 1.96, negative 1.96. Alright, so these are my critical zones here. And it's okay to draw it out like that if you need to do a mental picture, or if your mental picture is not good enough. Alright, so step 3, we want to calculate the observed value. Okay, so in step 3 we find out what does the z actually equal. So we know that the z formula is equal to m minus mu over standard error, right? We don't know what standard error is yet, so we have to calculate that first. Standard error is equal to that over that, so 15 over the square root of 30 is equal to 15 over, what's the square root of 30? Oops. So square root of 30 was 5.477 is equal to 15 over, that is 2.738 is equal to that. Okay, I boxed that. And now I can calculate that because I have enough values. So big M is 58 minus mu is 50 over that guy, 2.738. So 8 over 2.738 is equal to 8 over that is 2.921. Alright, equals a z observed. Box that. Step 4. Step 4, state results. So our z observed is bigger than our z crit. Z crit is 1.96. So basically this number landed beyond this critical region. So I like to write this. Z observed greater than z crit, comma, reject null hypothesis. Okay? This is bigger than this, so it does not equal this guy, or I'm sorry, it's not equal to this one, so we can reject that and basically use this hypothesis. Alright, so in step 5, since we reject the whole, we can state our conclusion, okay? And the question asks, can the researcher conclude that there is a significant difference in personality between only children and the rest of the population? Yes, the researcher can. So, we have to write it like this. Results suggest, always start with results suggest, that there is a significant, make sure that's your keyword, significant, difference in personality between only children and the rest of the population. Alright, and then we do this. Z equals 2.92, P is less than 0.05. Okay? Whenever we reject the null hypothesis, we say P is less than 0.05. if we fail to reject the null hypothesis, we have to say p is greater than 0.05, because the chance of that happening by chance is greater than 0.05. So again, rejecting the null hypothesis, p is less than your alpha level. Failing to reject the null hypothesis, p is greater than your alpha level. Okay? And then two-tailed. Period. Alright. In some instances, you might be asked to do Cohen's d, okay? In other words, that's effect size. So, if you are asked to do Cohen's d, and it never hurts to do Cohen's d, okay? So, the formula for Cohen's d is this. Alright? I'm just going to double check real quick. Make sure I got the formula right. Mean difference over standard deviation. Let's see here. Treatment, no treatment. Yes. So, sample minus the population mean over that. Alright, so Cohen's d, or is it d? It doesn't matter. So in this case, it'll be 58 minus 50 over 15. It's 8 over 15. 8 over 15, I think is 0.53. Let's see. Yes, 0.533. So what does that mean? So here we put, that's your effect size, okay? In other words, 53% of the effect can be accounted for by the treatment. In this case is being the only child or being in a large family. Alright? But in other words, 47% is explained by something else. Okay? So 53% of it, the effect can be explained by the treatment, but 47% is explained by something else. And 53% is not a really large effect size. If you guys look at page 233, a D of 0.5 is a medium effect size. Okay? A D of 0.8 is large. In other words, if we got a D of 0.8, that means 80% of the effect can be explained by being an only child or whatever, and only 20% of it is explained by something else. So that's why we can say it's a large effect size. So the D is the last thing you put here. Alright, hope that helps. Good luck, guys.